Stella Maris in Latin means star of the sea, and we thought that really appropriate, not only because of the way that the Stella Maris is built, and it almost looks like a star, if you will, but also in the fact that, it's a grounding point here for us in the ocean. COVE's mission is focused on advancing the commercialization of ocean tech. Nothing in the world exists that has this type of facility in a downtown core within such a large cluster, that has access to the waterfront like we do, and that has multiple businesses. So the Stella Maris is a really good example of how we operate within COVE and what we have to offer in terms of resources. We manage and operate onshore infrastructure for multiple uses and offshore infrastructure as well. So the Stella Maris fits well within that.
Well, the concept is quite simple, a test platform for everyone. A test platform for everyone at COVE, and regardless of what their sensor is or does or what their hardware is, just having real-time access to the ocean. Emphasis on the real time, like they can connect to it, they can talk to it, they can retrieve data, they can stream while it's in the ocean, and they don't have to wait to retrieve their sensor. So taking that concept and doing it 20 different companies can be a challenge, because whereas fundamentally everyone just needs power and communication signal, they all need something slightly different. COVE is a collaborative space, and this is a real piece of infrastructure that we can collaborate on and with. We've never really seen something this intricate. I could argue that we created one of the most sophisticated ocean-going platforms in recent years. These are the best sensors in the world. Being able to deploy them and showcase them to the local community and the wider ocean tech community is perfect in the collaborative nature of a place like COVE.
Stella Maris is just another good example of the knowledge sharing that's happening and the other business opportunities that are getting created. We've heard a lot of these success stories, and it's companies, by the very nature of doing their work here, have now bid into projects together because they understand the complementary nature of their businesses or their technologies.
RBR is a world leader in what they do, the CTDs, the conductivity, temperature, depth.
Just having all the different other sensor manufacturers and seeing what other people are working on, we're always thinking about what the next sensor is that we're going to be integrating and using, and what ocean scientists are interested in. So to see what other companies are doing, and then to think into the future, what other sensors could we start integrating on our CTDs. RBR measures the blue planet. So conductivity, temperature, and depth, so the CTD, is really important for oceanographers, but there's lots of other sensors that are important too, like measuring oxygen or pH. So we integrate lots of other company sensors onto our CTDs so that you can measure multiple variables all on the same platform, which is really, really useful.
Basically, we have a patent on an inlaid channel technology where we actually pump our water sample into that channel, and then we supply various chemicals to help that develop to a color. And then our sensor measures the color, and by determining the density of that color, we can determine the concentration of phosphate. It's important to measure the phosphate concentrations in wastewater coming out of treatment plants from a municipality, as an example. And runoff from agricultural applications is really critical. High concentration of nutrients in general, either phosphate or nitrogen, it causes growth in algae. And with the growth of algae, you get oxygen depletion, which can affect the aquatic life.
We're a designer and a manufacturer of piezo ceramics and hydrophones, and those are the acoustic sensors that you use underwater for listening and talking or creating images. Hydrophones are essentially listening, and so they're creating data points underwater of events that happen. So whether it's a ship that's moving through the port or the harbor, whether there's perhaps marine life, everything that moves underwater has its own specific frequency, and listening to those pitches underwater can tell you what's happening when you can't necessarily see it. These phones are very sensitive, so you can be hearing things from meters, hundreds of meters, kilometers away. How I think we can use the Stella Maris and the data that we collect with the hydrophones is how our sensors can work in conjunction with the other sensors that are deployed, understanding the differences between the different sensors, the data that you get, how you merge them all together to create more interesting data because it's more comprehensive. I think that's what makes this a really exciting project.
This could be something that, in 10, 20, 30 years, students are going back and looking at this data as a baseline.
Everyone's already lining up ways to take someone else's sensor data, combine it with theirs to offer more powerful analytics or ocean data. I think that's the very nature of what it's supposed to be, sort of happening organically. It's happening all by itself. We can't even stop it.
The Stella Maris allows companies located here to test their technology right on the wharfage in a natural environment. And they can do that and have access to data within seconds. And they can do that from their office and actually see what's going on right with Stella.
The local access is in the control center. And that is ultimately where we can here locally drive the platform from, or pull any of the sensor data, hopefully throw it up on screen in the control center.
I think what's exciting about real time is that that's the way of the future. We want to be able to make quick decisions, and this really simulates how that could happen out at sea or out really on any kind of mission. You want to be able to make quick decisions with the data that you have, and I think this is going to really showcase how that can happen in real time.
Before there was such a thing as portals, 15, 20 years ago, it was more of a discussion and a couple of photos of the users, or maybe even handing over the email address of a user locally. But with the real-time live data available at the trade show, we can actually show it on a laptop computer as we're giving that pitch to the client, whether it's in Singapore, or London, in the U.S., or wherever we might be. So even here in the office, we're sitting in our own office. We can point to the front of COVE and say our sensor's on the seafloor in about 10 meters of water. And it's very powerful.
There's the immediate wow factor of being able to display all of this multiple sensor data on multiple screens on a wall, and then when the navies and coast guards and ocean institutes of the world come around and take the tour of COVE, that's one factor. But a lot of people are also very interested in 3 months later, 6 months later, when we have 3 to 6 months worth of logged sensor data. That's what's of interest to, I think, academia. Students who are looking to corroborate and collaborate, and data seems to be extremely valuable these days, like almost more than the sensors in a lot of cases.
If you need to deploy something in the ocean, it's hard to do that in real time right now because especially if it's going deep, if you need a cable, you would have to take an instrument, put it on some sort of a platform, like a mooring line, for example. You need a buoy and a rope or a cable and a weights and everything like that. Some way maybe of figuring out where it is and then deploying it, going to recover it, and then you don't know then if it worked until you get it back. You cross your fingers and hope that it worked and that you set everything up correctly.
Platform deployments, very much depend on sea state and the crew, the boat crew, the diver crew, ROVs, if depending on how deep, where we're going. So Stella Maris, we have incorporated an interesting launch and recovery mechanism in the center. It's called a sea lift, and it's basically a quick release knuckle system. So that's never really been done before, to deploy platforms with such a quick release mechanism. And only because we have so much onboard monitoring, I think that we're going to be able to use it. But the plan is that this could be ROV, remotely operated vehicle guided, if we were in deeper water. The nature of these platforms really is, and the nature of the design is that we could drop them anywhere. We can connect multiple platforms together. We don't need to run a second cable for a second platform. We just connect platform 2 to platform 1. With that, we've created an ocean network here on the east coast of Canada, which doesn't yet exist.
The more we know, the better we can preserve the ocean. We need it for a lot of things, for not only for food, but for transportation, for the habitat itself. And so all of that information, I think, plays into how we protect it.
So I think for us, it's going to be a really awesome test bed right here in our backyard. We do have an office right here at COVE. So if we have a new sensor, it's going to be really awesome to say, oh, let's look at this data in real time. Do we need to change something? Do we need a new firmware upgrade? We could just go out, grab the sensor, pull it back, fix up what we need to do and redeploy. So I think that for us, it's going to be just such an amazing test bed to have right here and to have the data right away so we know things that are working and aren't working for all of our future sensor development. It's going to be really awesome.
Well, I think it's a tremendous opportunity for the tenants at COVE, and we're looking forward to interacting with the team here at COVE and all the other tenants, because it's basically a cluster effort, because it really is all about the people and the teams, and that is really helpful when you're trying to bring a product to market.
So we're really focused right now on our expansion. So our expansion in space and in program. What we've been able to create is a really interesting mix of different companies and different organizations, anywhere from the early stage startup to that global enterprise.
I really love working at COVE. The view isn't the biggest draw, but it is a big one. We love working right on the ocean. But just seeing all the other companies and hearing about their projects and what they're working on is always just really great to think longer term.
Well, one of the reasons we chose COVE was because of the collaborative nature of being around other ocean tech companies. And we've been around for 38 years, so we've done okay, but that said, part of the attraction of coming to Nova Scotia was COVE. We've gotten to know a lot about what happens in ocean tech just by being here.
COVE is at the heart of Canada's ocean tech cluster. And what we're seeing here in Nova Scotia is really that we have an ocean advantage.